Forsack had never experienced anything like it. He felt as if he were in a sci-fi movie. Initially, there was the same pale green light. It got greener and brighter. It began to glow, and through its luminosity, he could see a trail of blood. The trail was solid, but with streaks in it, as though someone had taken a big wet mop and wrung it out and dragged it along the floor. The length of the bloody trail measured some 55 feet. The shimmering glow hung in the air above Fossack's knees. It became so bright that he could see the faces of the forensic men and the chemists. Peter Mass. It's from a book called In a Child's Name, The Legacy of a Mother's Murder. Hello everybody, my name is Darrow. I am the host of the podcast that isn't only science-based, but we'll also cover some history too. All opinions involved in this podcast are my own, and here we hope to spread some knowledge and understanding of the world around us and where this all came from. This is Class Half Full. Welcome to episode 2, Class Half Full. Today we're going to cover luminol. Luminol is the chemical we all know about from, I imagine, CSI and other crime programs, where they go in, they spray a dark room, and it glows up a bright blue. In this episode, I'm going to cover what it is, how we make it. It's not readily available, so it's made. Some of the history of it, where its footsteps came from in forensic science. Going to say how it works and how it's applied within a crime scene. And we might wrap up with a case study or two. So let's get cracking. So what is luminol? Luminol is a hydrocyclic compound that has chemiluminescent properties. For those of you who don't know what chemiluminescent is, basically a chemical reaction that will produce light. And a bit further detail into that, it's when there's a molecule that is capable of fluorescing. It emits light. So this will happen during a chemical reaction, and the electrons will be excited to a much higher energy level state. And as the energy returns to its ground state, this energy is released via light. And this is the blue glow you'd see through luminol. Luminol's chemical name is 3-aminophthalhydrazine. Chemical formula is C8H7N3O2. So that's 8 carbons, 7 hydrogens, 3 nitrogens, and 2 oxygens. Now, luminol is not really readily available. Yes, there'll be manufacturers who will make it as a ready-state compound, but it has to be made. So your starting ingredients as such for this will be 3-nitrophthalic acid and hydrazine, and this will all be mixed in a high-temperature solvent such as triethylene glycol. So you heat this mixture up and you're essentially creating a dehydration reaction, so you're removing all the water, and you create this intermediate compound called nitrophthalhydrazide. So on a side note of that, if you're ever in the world of, synthesizing compounds, etc., and you have intermediate stages, I would advise checking up on them, because it doesn't always work. So you do this through infrared spectroscopy, NMR, mass spec, whatever you have available to you. So just a little side note to double check your intermediate stages. This compound is then reacted with sodium dithionite. So it's a reduction reaction. So we're looking to reduce the NO2 to an NH2 on the compound. And then you get luminol. Where did this molecule come from? We're going to take a little journey through the 20th century and see some of the processes that were covered and how it ended up being in a forensic scientist toolkit. So the first time it was synthesized was in Germany by a scientist called A.J. Schmitz in 1902. This was done under the direct direction from his supervisor, Professor Curtius. And at this moment in time, no one really knew any uses or any of the chemical properties of the compound that they've just made. So it was later on in 1913 that Professor Curtius synthesized it again, but he done it in a slightly different way. And again, other properties were figured out, but the chemiluminescent property, the property that's so important to this story, was not discovered at this point. So somewhere between 1913 and 1928, a scientist, W. Luminol, from Leverkusen in Germany, discovered the chemiluminescent properties of luminol, and this was during an oxidation reaction within an alkaline solution. He then took this to the attention of one of his colleagues, H. Katuski, who then managed to interest another scientist by the name of O. Albuquerque. He managed to convince him to look into these properties and then published the results. So these results were published in 1928. What he found was that a number of oxidizing agents could be used within an alkaline solution to produce the luminescence. He also noted that the luminescence was visible in the dark, and compounds such as hyperchlorates or ferrocyanides enhanced luminescence in the presence of hydrogen peroxide, as well as plant peroxidase and blood. So it was actually in 1928 that blood and luminol made their connection. Within the same paper, he also noted that a catalyst is required. So up until 1934, luminol was known by its chemical name, 3-amino-alhydrazine. And it was within a paper from Huntres et al. He showed the synthesis from the 3-nitrophthalic acid and the hydrogen sulfate. And in the end product, they called it luminol. So it was 1934, luminol gained its, I suppose, trade name. In 1936, the quantum yield was figured out, and crystalline structures such as hemine produced intense luminescence. And this was later confirmed in 1937. 1937 is another interesting year for luminol, as a scientist called Walter Spiech. He done extensive studies, and his intention for these studies was to use luminol in a medical legal situation. So basically just to identify blood based on its chemiluminescence. He did these studies on old and new blood stains. He managed to reliably detect them all using 2 luminol reagents. One of these reagents consisted of 0.1 grams luminol, 5 grams calcium carbonate, which was mixed with 15 mils of 30% hydrogen peroxide, and it was made up to 100 mils of water. The other solution that he used was 0.1 grams of luminol again, and this was in 100 ml of a 0.5% aqueous sodium peroxide solution, and he noted within his study that both worked well. He also looked at other substances the same way that he looked at the bloodstains. So some of these were milk, coffee, semen, saliva, urine, leather, leaves, waxes, metals, and way more. There's a fairly extensive list of what he looked at. And he reported that they all gave negative results. He suggested that spraying was the best way. And he also, at this point, noted that a good way to record the results would be to take pictures. So after his paper, he highly recommended this to be used for medical legal examinations. Later on in 1939, 2 San Francisco pathologists looked at Spiech's work, and they repeated it and confirmed his work, but they also found other patterns. They found that older bloodstains would give more intense luminescence than the fresher ones. And they also discovered that if the luminol dried up, you could reapply it and re-get your luminescence so that the process could be repeated. So it wasn't until 1942 that luminol was recommended to be taken to crime scenes for forensic work. It was also noted in this paper that older stains give more intense reactions. It wasn't until 1942 that luminol was recommended to be used for forensic work. It was in this same paper that it was also noted and confirmed that older stains gave more intense reactions. And it was concluded in this paper that this was due to the breakdown of hemoglobin in hematin within blood. The scientist involved in this believed for it to be fairly specific for blood, as he tested it against other bodily fluids, as other scientists have. Other bits he tried on was wood and spoiled vegetables. He did caution in his paper that it should not be a standalone test, and this was based on a paper he read the previous year that stated it was a good presumptive test, but was not specific to blood. And within this same paper, just a note of interest, the lambda max, or the maximum wavelength of the chemiluminescence was for luminol was recorded. So that was 441 nanometers. This shifted to 452 nanometers with older stains. It wasn't until 1951 that luminol was recommended to be added to senior crime officers' test kits. The scientist involved in this suggested it, but he stated that they had to be packed in their reagents, and the reagents had to be added in a certain order, which would be crucial because of the solubility of the components to get it to work quicker and to its most efficient way. Jumping forward to 1973, this is when extensive studies started going into the photography of luminol. So in the paper mentioned in 1973, it was different photographic films and exposure times, because they didn't have fancy cameras at the time. These were investigated, the optimum was figured out, and it was later suggested that these photographs should now be used as evidence. And basically from 1973 onwards to the present day, we use the same sort of process. So the guys have all the reagents in their kit. When they go to the crime scene, they'll mix them together and do what they have to do. We'll explain further down the line what we would do at a crime scene with luminol. And basically, that was that. So now I think we should talk about a little bit how it works. Not too extensively, but just a brief A plus B equals C type scenario and some of the things that may affect it. How does luminol work? As mentioned before, we know that luminol doesn't act on its own within the bottle. It's combined with other chemicals, which are vital for the reaction to take place. So one of the first additions to this is a strong oxidizing agent. So this would be, it's typically hydrogen peroxide. So this is one of the chemicals that's directly involved in the reaction with luminol. We're also needing a basic solution. So this is just an alkaline solution. So it needs to be added. So typically sodium hydroxide will work for this. The necessity for the basic solution is when luminol is in a neutral solution, it forms what is known as the ionic structure. Basically, all that means is there's both positive and negative charges within the molecule. So by adding the basic solution, we form an anion, which is just a negatively charged molecule, and it's easier to oxidize this with the oxidizing agent. And as stated again from the history part of it, this is not all that's required. We're also in need of a catalyst, to speed this reaction up a bit, to get it moving in the right direction. So this is where, in the crime scene side of it, is where blood comes into it. So blood has hemoglobin within it, and within the hemoglobin is iron atoms, and it's actually the iron that acts as the catalyst between luminol and hydrogen peroxide, giving off the luminescence. So basically a cyclic peroxide is formed, which gets decomposed to give the chemical or the molecule 3-aminophthalate. So the reaction releases energy. So we're coming into how this chemiluminescence works here. The reaction releases energy, which is transferred to electrons in the 3-aminophthalate molecules. This promotes them to a higher energy level. And as the electrons drop down to a more stable energy level, i.e. down to their ground state, they release the excess energy as photons. The release them as photons as light, which results in this, the blue chemiluminescence we all know and have seen in the movies and TV and whatnot. That's the basics of it, slim basics of it. Fun fact about when using luminol, it can detect blood dilutions to 1 part per million, which is a fairly sensitive presumptive test to have, which is great because people try and clean things up and hide things. So the lower concentration you can detect, the better chance you saying, yes, this is blood here. So when arriving at a crime scene, I would say it's one of the last things you would look for if you thought that a serious crime had been committed, as it's a destructive test. It can destroy other pieces of evidence. It can destroy fingerprints and other components of evidence. So you'd want to process the whole crime scene first. And if you find maybe one speck of blood and it was in a weird place, like behind a telly or something, you'd probably go, maybe we should luminol this area. So what would happen, that area would get closed off, all samples and other pieces of evidence will be taken. Ideally, somewhere in the area, a couple of swabs should be taken just in case. The room will get darkened off, camera will get set up, sockos will mix their chemicals together, and they'll spray around the room. Now, it's not as the way it is in CSI, where they kind of go, there's blood here, and they spray absolutely hundreds of the stuff absolutely everywhere, and the whole room lights up, and it's great for everyone to see, and they flash their UV light. Mythbuster number 1, UV light not required. You can see it with the naked eye in the dark. So once you've done this, you set your camera up. Your camera will be set up for a long exposure and a slow shutter speed. That way there's more exposure of the light getting into the film to take the picture, and you can get a better, clearer picture of it. If luminol, if it does light up at this point, you might find that scenes of crime officers and the forensic scientists whatnot decide will tear the carpet up or will look under the floorboards to see if they can find any fresh or uncleaned blood. And that's pretty much that. It does have its disadvantages, as it is not a specific test for blood. There's other things that can catalyze the oxidation of luminol. So one common one's bleach, and it's a nightmare for crime scenes and whatnot, because for some reason, when a horrible crime's been committed, people go, I'll clean it with bleach, and the bleach leaves sodium chlorate behind, and that can oxidize it can catalyze the oxidization of luminol. It takes very well trained officers to look at it and say that it's bleach, or there's apparently some officers in the world that can gauge how old it is by how bright it is, which kind of makes sense. If the older the blood stain, the brighter it glows. Other things, blood within urine or peroxidase enzymes. Other things like horseradish has got peroxidase enzymes in it. These are all things that can give you, say, a false positive for luminol, which is just a real strong headache. Maybe 7 times out of 10, false positive is unlikely, but these guys are well trained. They've got all their controls in place, and they know what they're doing with it. So it's very, very, very unlikely. Another disadvantage is it doesn't actually glow as long as is made out. So when you watch programs like CSI and in the movies, they spray it and it glows for ages. And they're even away onto their next part. They're talking to people and it's still glowing in the background. It's not really the case. It can glow for a while if you've got the right setup, but mostly it only really lasts around 30 seconds. So that's just another disadvantage of it. And I think that's all I've got to say on the crime scene and how it works. Anybody got any questions, just ask. I'm going to now go on and talk about a case study or two. We'll see how we're doing. These are just basically, they're not like Luminol solved the crime, because Luminol can't solve the crime. It's a presumptive test that say it may or may not be here. It's a reaction, should be sampled and taken to further testing before anybody jumps to any conclusions. The first case I'm going to talk about is one that was here in Scotland, in the west of Scotland, maybe 15, 20 miles up the road from where I am now. I was in a town called Govan. So a couple of case studies now. Like I said, the first one we're going to look at happened here in Scotland, Govan, Glasgow. This is the murder of Julie Riley. She was 47-year-old at the time she was reported missing. And she was reported missing in February 2018. It was a missing persons case for a couple of months. It wasn't launched as a murder investigation until April in that year, once one of her bones was found at a fox's den. It was a man by the name of Andrew Wallace who pled guilty to her murder. He got 28 years for a murder and for attempting to defeat the ends of justice. So Andrew and Julie knew each other because she originally suffered a brain injury, and she asked Andrew to live with her in December 2017 in hopes that he could take care of her. What I'm saying, we can guess that ended quite differently. Wallace reportedly killed Julie after some sort of confrontation. They had an argument. There was a knife involved. And in the end, he ended up dismembering her body. He put parts of her in a suitcase and buried others in other locations in Glasgow. It was 3 months after the sentence that Andrew revealed where the rest of her remains were. The whole length of the investigation took 15 months, and where Luminol comes into play for this is the police were at Julie's house for a considerable amount of time. And from the footage that I've seen and stuff like that, there didn't appear to be much out of place. There didn't seem to be much of a struggle. It looked lived in, but tidied up. And it wasn't until the murder investigation part was released that without a crime scene, it's hard to put everything together. So one of the officers found a speck of blood. There were specks of blood here, there, and everywhere, but when you see that, you can't say this is where the crime scene was. So they decided to conduct the luminol test throughout the house. So they shut the house off, made it as dark as possible, and proceeded with it. And it showed that a horrific crime had been committed. And it was from then that helped saying that this was where the crime happened and she was definitely murdered. So I'm now going to go on to a case that was in Ireland. It was at the Royal Canal, I'm sure they called it. Basically, unidentified male torso and dismembered body parts were found in the canal. So this is in Dublin. They also noticed that the victim had been decapitated. The full canal was searched, but no personal items were found that could help identify the body. Samples of bone marrow, tissue that was still there were sent for DNA profiling. They were able to get a full DNA profile from the samples, but there was no other clues to identify the person. So basically, if they ran it against their system, this man was not in it, so it had not been known to the police for anything. It wasn't until some time had passed that a woman reported to the local police that her partner had not been to visit their son in a fairly long time. So a paternity test was carried out using the samples from the bone marrow, and it showed that the body in the canal was the biological father of this child. So following on from this information, the detectives were led to a nearby flat. So that was the last known place that the victim stayed with his new partner. By this point, the flat had actually been occupied by new tenants and had been recently redecorated and whatnot. So it's when the forensic scientists located a small amount of blood on the skirting boards in the house. There was some along the bedroom furniture as well. As normal, at this stage, it can't be determined if this was the actual scene of the crime, as there wasn't any large volumes of blood anywhere to say that, a body had been dismembered here. So this is, again, where luminol comes into play. The testing was carried out over several areas of the flat, including the bedroom door, and that showed that there was large volumes of blood that were present in the flat prior to cleanup, and the blood stains showed the same DNA profile as the body in the canal. So there was no doubt in the investigating officer's mind that the murder happened at that location, at that flat. The victim's new partner and her 2 daughters were questioned, and they were actually finally charged with the crime. So they were quite short case studies with a wee bit of information about them, but it just shows that a simple technique such as luminol to determine the presence of blood can give police a lot of information, especially if a crime scene has been, tidied up and cleaned up. Both these cases, there were dismemberments, so there would have been a lot of blood present at the scene of where this all happened. So it helps put things at a place and at a location for them to start building outwards from there. And that's the episode of Luminol. I'd like to take this moment to thank everyone for listening to the latest episode of Class Half Full. We really appreciate your feedback and any of your comments, so please keep them coming. You can email any questions or any feedback to classhalffull@outlook.com. You can find us on Instagram, classhalffull6. You can find us on Twitter, class_half. And we now have a Facebook page called the Class Half Full Podcast. Come along, like, subscribe, review, ask some questions, and just get joined in the chat. Hope to see you in the next one. And that's Class Dismissed.